In this video, we're going to be talking about how to find the cross product of two vectors, and in this particular problem, we've been given vector A with its direction numbers 5, -1, -2, and vector B with its direction numbers -3, 2, and 4. So we have these two vectors, we want to find their cross product. And to find the cross product is really pretty simple. All we're doing is putting these two vectors into a matrix with I, J, and K, and then solving the matrix. So here's what the matrix is going to look like. We're going to start with a 3 by 3 matrix, and in the top row we always put I, J, and K. Then we'll do A in the second row, so 5, -1, -2, and B goes in the third row, -3, 2, and 4. And now it's just a matter of solving this matrix. The most important thing is to remember this table here for signs. Whenever we're solving a 3 by 3 matrix, we have to remember the signs in this first row here, and we'll come back to that in 1 second. But when we solve this matrix, here's what it's going to look like. We're going to take the first value in the first row, I, and we refer back to our diagram here. We can see that the sign on I is going to be positive. So we have positive I, and then we multiply that by everything that's not found in the same row and column as I. So I is in the first column here, so we're going to ignore everything in the first column. It's also in the first row, so we're going to ignore everything in the first row. In other words, if we put a box here around I, like this, we would want everything that is not in the same row and column as I, and we just transfer this to a 2 by 2 matrix that we multiply by I. So this then just becomes -1, -2, 2, and 4, exactly in the formation that it's been given. Then we're going to take the second value, J, but notice here that J always has to be negative because the sign on that middle value in the top row has to be negative. So this is always going to be minus J, and then we multiply it by its 2 by 2 matrix that's not found in the same row and column as J. So if we say that J here is in the top middle, we take everything that's outside of the same column and the same row as J. So that's going to be these two values and these two values that are outside of the row and column with J, and we transfer those to this 2 by 2 matrix. So we get 5, -2, -3, and 4. And then here we can see that K is going to be positive, so we say positive K, and we multiply that by the 2 by 2 matrix that we find when we take everything outside of the same row and column as K. So we take K here, and everything outside of the same row and column as K is this group right here. So in that case, we'll transfer it in exactly that same configuration, 5, -1, -3, and +2. Now we can just simplify these 2 by 2 matrices, and the way that you do that is you take the top left and you multiply it by the bottom right. So you take -1 times 4, and then you subtract the product of the lower left and the top right. So minus +2 times a -2. Then we're going to subtract J and multiply here by upper left times lower right. So 5 times 4 minus lower left times upper right. So minus -3 times a -2. And then we're going to add to that K multiplied by upper left times lower right, 5 times 2 minus lower left times upper right. And it's always that same multiplication pattern. So -3 times a -1. And now we'll simplify. So we'll get I, -1 times +4 is a -4. 2 times a -2 is a -4. So we have minus a -4 or plus 4. Then we've got minus J, 5 times 4 is 20. -3 times a -2 is a +6, so we end up with minus +6. Then we get plus K times 5 times 2 is 10. -3 times a -1 is a +3, so we end up with minus a +3. And when we simplify again, -4 plus 4 is 0, so we're going to get 0I, or just 0. That whole term will fall away. And then we're going to end up with 20 minus 6, or 14, so we end up with -14J. And then here, 10 minus 3 is 7, so we get plus 7K when we move those coefficients out in front of these values here. So we can either leave the cross product vector in this form, or we can call out the direction numbers of this cross product vector. The way that you write the cross product is A times b like this, this means the cross product of the vectors a and b. So we could say the cross product of a and b is negative 14j plus 7k, or we could say cross product of a and b is going to be the direction numbers 0, because the coefficient in front of I was 0. So 0, negative 14, 7, and any of these would be acceptable answers. I'd probably give this second answer with the direction numbers called out 0, negative 14, and 7, because the original vectors were given to us in the form of direction numbers as opposed to the vector function here in terms of I, j, and k. But either way, both are acceptable answers. That's how you find the cross product of two vectors.